So currently we are focusing on the micro sensors and micro transducers for micro robotic system. So in the last two lectures we had discussed about the gyroscopic accelerometers, the different configuration of gyroscopic accelerometers, the mechanical switches. Now we will discuss about the flow transducers. As far as these flow transducers are concerned, a transducer is a device which we all know, which converts from one form of energy into another form. So as far as these flow transducers are concerned, these are a specialized transducer that measures and monitor the flow rate of the fluid, and it converts this information into an appropriate electrical signal. Now, some of the key importance of this flow transducers in micro robotics is concerned. So it is mainly meant for precision measurements, that is, it enables accurate monitoring of minute fluid movement in microscale environment. It gives us a real time data, and it provides an instant feedback for micro robot navigation and control. As far as versatility perspective point of view, it is applicable in various microfluidic systems and environment. As far as integration perspective point of view, it facilitates the development of smart, responsive micro robotic system. Some of the key components of these flow transducers includes the sensing elements which detect the changes in the fluid flow. Examples like thermal sensor, pressure differential sensor, ultrasonic emitter and receivers, etc. Now, with reference to transduction element, it converts the detected flow information into electrical signals. It may involve various principles like piezoelectric, electromagnetic, capacitive, etc. With reference to functionality perspective point of view, it measures the flow rate, the velocity or volume of fluid passing through a specific point, and it provides a continuous real-time data on the fluid movement. So these are some of the key aspects with reference to the flow transducers. Now, like with reference to feature perspective point of view is concerned, it has a very distinguishing features. One is it is a high precision in measuring small scale fluid movements. Like even we have been discussing about this magnetic based micro robots or this electrostatic based micro robots. In all these cases, there is a need to measure a kind of a micro displacement in this particular systems. In order to measure these micro displacements in a particular domain, so these flow transducers should be capable enough in such a way that it should have a high precision in measuring a small scale, and it should have a ability to function in the microfluidic environment, and it should have an integration capability with respect to microelectronic systems. An output perspective point of view, typically it produces an analog or a digital electrical signal. The signal amplitude or frequency is often proportional to the flow rate. On an applications perspective point of view, the application in micro robotics is in concern. It is more towards navigation and fluid environment. It has a precise fluid handling in lab-on-chip devices. Monitoring and control in microfluidic system is considered to be one of the key applications of these micro robotic systems. Now, let us discuss about the energy conversion mechanism. With reference to energy conversion mechanism, the flow transducer converts the physical force of the fluid flow into an electrical signal. This conversion allows for easier handling, transmission and measurement of flow data. So when we try to consider the measurement methods, we have the thermotransfer method. The thermotransfer method uses heat transfer to measure the fluid velocity. It employs heating element and thermal sensors to detect the energy absorption by the fluid. Next, with reference to time of flight method is concerned, it measures the time taken for ultrasonic pulses to travel between the transducers. It also calculates the flow velocity based on different in transit times. And there is one more configuration which is called as a magnetic inductive principle. This magnetic inductive principle ideally utilizes a Faraday's law of induction. A conductive medium flowing through a magnetic field generates a voltage proportional to the flow velocity, which is being represented by the magnetic inductive principle. Next is called as a vortex principle. So, as far as vortex principle perspective point of view, it detects the vortices generated by the fluid flow passed as a bluff body. There are number of vortices which correlates with the flow rate. As far as real-time monitoring capabilities are concerned, it provides a continuous and instantaneous data on flow rate, pressures and temperatures, and it enables a process optimization and early identification of the systems, and it facilitates a remote monitoring and a control through the integration with the IoT platform. Next important aspect is with reference to the signal processing. As far as signal processing perspective point of view, it has an advanced electronics and microprocessor process with reference to the raw flow data. It converts the measurement into a readable format for the operators. By employing these principles, a flow transducers offers accurate real-time flow measurement across various industrial applications, which enhances the efficiency and control the fluid management systems. Now, when we closely observe the role of a flow transducer in micro robotics is concerned, so one of the key role of these flow transducer includes navigation and sensing, that is the fluid environment mapping. This fluid environment mapping enables the micro robot to detect and navigate through the complex fluidic channels as well as networks. So, either it might be a blood flow, or it might be a kind of a ocean flow, or sometimes it might be a kind of a small lubricant, where through the lubricant when such kind of flow needs to be analyzed. So, these should be quite capable. Next is with reference to obstacle detections. So, with reference to obstacle detection, it will help to identify the obstruction or changes in fluid dynamics for safer navigations. The most important point is with reference to the precision control. In the case of a precision control, it has an accurate fluid manipulation. It allows for precise control of fluid flow in microfluidic device and lab on chip system. A feedback mechanism which provides a real-time data for adjusting the micro robot movement and the orientation. With reference to micro reactor system perspective point of view, a flow rate monitoring which ensures the optimal condition for chemical reaction and synthesis at a micro scale, and process optimization is concerned, it enables a fine tuning of fluid dynamics for improved efficiency and yield. Now, with reference to biomedical perspective point of view, so it is highly used for in vivo sensing. It facilitates the measurement of a blood flow or other bodily fluid in minimally in an invasive procedures. So, with reference to drug delivery perspective point of view, it enables precise control of medication release in a targeted drug delivery systems. The environmental monitoring perspective point of view, it has a pollutant detection. It allows the micro robot to sense and quantify contaminants in the fluid environment. And water quality assessment perspective point of view, it provides a data on flow characteristics in the water treatment process. Performance enhancement a perspective point of view, we have the energy efficiency. It optimize micro robot movement to reduce the power consumption in the fluid environment is one of the major aspect which needs to be taken up into consideration. Next is with reference to adaptive power. These adaptive behavior which will enable the micro robot to adjust their strategies based on the local flow condition. Now, let us discuss about the thermotransfer method. So, as far as this thermotransfer method is concerned, this method relies on the principle of a heat transfer to determine how fast a fluid is moving through a channel. So, when we try to consider the principle of operation, the thermotransfer methods operate by utilizing a heated sensor element placed in the fluid flow. As the fluid moves past this heater, it absorbs the heat. So, the temperature difference between the heated sensor and a reference sensor which measures the ambient fluid temperature is monitored. The greater the flow rate, the more heat is carried away from the heated sensor, resulting in large amount of temperature difference. So ideally this will be the kind of a heater location and the sensor will be placed appropriately. So this will be helpful for us to measure the reference and the output, the influence of the heater towards the flow. As far as the measurement process is concerned, so as we had discussed earlier, a heating element, which is a kind of a resistive type temperature detector, acts as a heating element. It maintains a constant temperature above that of the surrounding fluid, and a temperature sensor, two temperature sensors are used, one for measuring the temperature of the heated element and another for moving the temperature element. So here the resistive temperature heaters / detectors can also be used. However, like in certain cases, these resistant temperature detectors itself can act as a sensor. Now, with reference to flow rate calculation perspective point of view, the flow rate can be determined by analyzing the temperature difference del T between these two sensors. As the velocity increases, the heat transfer increases, leading to a measurable change which is considered as del T. So, next we will discuss about the time of flight method. So, as far as this time of flight method, it is mainly meant to measure the time taken for a signal, ideal in thermal or acoustic, to travel between 2 points in a flowing fluid. The flow velocity affects this travel time, allowing for accurate flow calculation. So, as far as this time of flight method is concerned, so it is classified into two. One is called as a thermal based time of flight, another one is called as a ultrasonic based time of flight. So, in the case of a thermal based time of flight process, when we try to consider the working mechanism, the heat pulse generation, that is, a heater element creates a brief temperature mark in the fluid, and when we try to consider the downstream detection, so the two temperature sensors which are positioned are used for measuring the downstream at a known distance and detect the passing of this thermal mark. As far as the time measurement is concerned, the time difference del T between the mark detection at each sensors are measured, and in order to calculate the velocity, a flow velocity V is calculated using the equation L by del T. So, L is the distance between both the sensors. Now, when we try to observe the working mechanism, so this is a kind of an, the next configuration is called as an ultrasonic time of flight method. So, in the case of our ultrasonic time of flight method, so we need to discuss the working mechanism. So, where there is sensor 1 which is at one particular position, and the signal from the sensor is collected by a sensor 2. Now, this ultrasonic transducer emits sound pulse both upstream and downstream. So, when we try to calculate the transit time measurement, the system measures the time taken for a pulse to travel in both the directions. So, the time difference calculation is concerned, the difference in transit time del T between the upstream and the downstream pulse is determined, and the flow velocity calculation is concerned, the flow velocity V is calculated using the formula V equals L by T into del T, T up and T down. So, T up is the transit time for the upstream and T down is the transit time for the downstream, and L is the distance between the transducers and V is the velocity of the system, and del T is the difference in the transit times. Now, let us discuss about the next configuration, which is called as a magnetic inductive principal configuration. So, in this magnetic inductive principal configuration, the key components, so if we consider this as a system, so we have two electrodes and a magnetic field is placed and the fluid is moving with the velocity V. So, the key components involved are the magnetic field generated by the coils, the conductive fluid flowing through the pipe, and the electrodes to measure the induced voltage. With reference to working principle perspective point of view, a magnetic field is created perpendicular to the flow direction, As the conductive fluid flow through this magnetic field, it acts as a moving conductor. This movement induces a voltage across the fluid perpendicular to both magnetic field and the flow direction. This induced voltage is measured by the electrodes placed on the opposite side of the pipe, and the voltage is directly proportional to the complete flow velocity. Now, when we try to mathematically represent this, the relationship is expressed as E is the induced voltage, B is the magnetic field strength, V is the average flow velocity, and D is the diameter of the pipe. So, E is proportional to BVD. So, B is the magnetic field strength and V is the average flow velocity and D is the diameter of the pipe. Now, let us take the vortex, let us take the next configuration, which is called as a vortex principle. So, when we try to consider, so in the case of vortex flow based measurements, these techniques are based on the principle of vortex shedding. That is, the key components involved in this are the bluff body, specially shaped obstruction placed in the flow path. As far as sensor perspective point of view, typically piezoelectric or capacitive detects the vortex induced vibration. With reference to signal processor point of view, it converts the sensor data into a flow rate measurement. The working principle perspective point of view, it has a vortex formation. As the fluid velocity reaches a critical point, the vortices behind the bluff body, these vortices alternated from side to side of the bluff body. Now, as far as pressure fluctuation perspective point of view, the vortices creates an alternative zones of positive and negative pressures, and these pressure changes occurs at a frequency proportional to the flow rate. With reference to detection perspective point of view, the sensor detects the pressure fluctuation or vibration caused by the vortices. This generates an electrical signal with a frequency matching the vortex formation rate. With reference to signal processing perspective point of view, the signal processor analyzes the frequency of the electrical signal using a known relationship, and it converts this frequency into a kind of a flow rate measurements. And next configuration is called as a Coriolis flow configuration. These Coriolis flow sensor are advanced devices used to measure the mass flow rate, density and the temperature of the fluid with high accuracy. These sensors operate based on the Coriolis effect, and it provides a direct mass flow measurements without the need of the additional calculation. Some of the key components of these Coriolis flow sensors include a U-shape or a straight flow tubes, magnetic and coil sensors, and the electronics unit for signal processing. So, based on the requirement, so we can appropriately change the configuration of this Coriolis flow sensor. Now, when we observe the working principle of this Coriolis flow sensor, the flow tubes are electromagnetically vibrated at their natural frequency. As the fluid flows through the vibration tube, it experiences a Coriolis acceleration, causing the tubes to twist slightly. The twisting motion is proportional to the mass flow rate of the fluid. Sensors at the inlet and the outlet of the tubes detect this twisting as a phase shift between the vibrations at each end. These phase difference delta T between the inlet and the outlet vibration is directly proportional to the mass flow rate. The electronic unit processes this phase difference to calculate and output the mass flow rate. The vibration frequency of the tube is used to determine the fluid density. Temperature and sensor compensate for thermal effect, and it provides the process temperature data. So, ideally these tube oscillations will also be helpful for the overall mechanism in order to maintain a kind of a uniform flow. Next important configuration is called as a triboelectric nano generator based based flow sensor. So as far as the principle behind this triboelectric nano generator is concerned, you can see over here. Like it works on the principle of an electrostatic charge. So we have a tribo-positive material and a tribo-negative material. So here what we are considering is, so we are directly inducing a tribo-negative material and 2 electrodes are placed in this, and what we are trying to do is, so we are trying to go for a water droplet in this particular system. So when these water droplets are generated, so what happens is this water droplet will made to flow in a particular direction, so which will initiate a kind of a charge. So this can be used to monitor the overall flow rate. Like suppose, so if we have a kind of a micro robotic system, so in the overall flow of this micro robotic system can be efficiently monitored using such kind of triboelectric nano generator. So the interesting part of this triboelectric nano generator based flow sensor is, these triboelectric nano generator integrated flow sensor can be at a kind of a minimal level, so that when the water flows on it, the water, like which is in a positive charge, when it hits the triboelectric material, so appropriately we can see a kind of a change in the overall characteristics of it. Based on the change in the characteristics, so we can study the overall flow rate. So in this particular video also we can observe, like this is the kind of a triboelectric negative material, and when the flow is made to hit the surface, because of the positive node of this particular water droplet, we can continuously monitor the shift in the charge. Now the triboelectric nano generators can be formed by combining 2 material having a different electron affinity. The fluid of tribo-negative and tribo-positive property, when it flows over the material with different electron affinity, and electrical signals will be generated. Depending on the flow velocity and the voltage signals generated will change, and the higher velocity will generate a higher voltage. So this also comes under the category of self-generating system, so that the self-generating system has a capability to propel the micro robotic systems appropriately. So this can be this is a kind of a new technology which it can be used for encapsulating these micro robotic structures for self-powered systems. Now let us discuss about the haptic interface. So a haptic interface is considered to be one of the key elements for a micro robotic system as well as a macro robotic system. So that we will discuss in detail in the upcoming classes.